Thank you for joining us. You're here to talk to us about the Teledyne FLIR T-Series thermal cameras. I'm Jess from Path, and today I am joined by Jason Cargil, Teledyne FLIR's Technical Sales Specialist. Welcome.
Hi, thanks.
Thank you for joining us. You're here to talk to us about the Teledyne FLIR T-Series thermal cameras and talk us through the range and some of the features and the capabilities. We hope you find this informative and interesting. However, if we do miss anything, please leave a question in the comments for us, and remember to like and subscribe and share this video with anyone you think might benefit from it. So when we talk about the Teledyne FLIR T-Series thermal cameras, which models are we actually talking about?
Essentially, we've got two examples today, Jess. We have the T8XX or the T800 series, and we have the T5XX, which is the T500 series.
Yeah.
Physically, to look at, the main difference you'll see straight away is there's a viewfinder and an eyepiece on the 800 series. There isn't on the 500. The 800 is used mainly with the viewfinder and with the eyepiece for outdoors. It's particularly useful if there's any glare on the screen when you're looking at something from an outdoor perspective. So the viewfinder is used a lot with utilities companies, for example, who do a lot of external thermography. So that's one of the key differences. We then look at the range as a whole, where we move up through different thermal resolutions. So for example, we start with a T530, which is a 320 by 240 detector, and that's what the 30 means with the name. So the 5 is the model range, the 30 denotes the 320 by 240 detector. We then move up to a T540 and a T560, again moving up in resolution. So T540 will have, so you'll go from 76,800 pixels with a T530, then it's about 161,000 with a T540, and it's approximately 307,000 with a T560. So you've got three resolutions within the 500 series, and then with the 800 series we have a T840 and a T865. Again, the second number denotes the resolution because it's a 6. The T865 is a 640 by 480 resolution, again, which is also available in the 500 series. And we have the T840, which again is similar to the T540 in regards to resolution, but without the eyepiece on the 500 series. So we have a nice spread of infrared thermal resolutions throughout the T-series range.
Yeah. And we should say we don't have one with us today, but there's the flagship model as well, isn't the T1020.
Yeah, we have the T1020. So it's slightly different to these models because it's also been in the range for a slightly longer period. Thermography perspective, it has the highest resolution as a standalone thermal camera.
Please could you talk more about the differences between the models and ranges?
The main differences, we talked previously about the TXXX range, for example, which is a pistol grip camera. We can see quite clearly that this is not a pistol grip design. So what this model has and what the T-series have as a model range is a rotating optical block. So essentially with the rotating optical block, you can point the lens up to an area that you're interested in, whereas you're still looking down comfortably at the screen. So as long as you're not moving around, because you need to be able to see where you're moving to, essentially this can be a very comfortable way to utilize the rotating optical block. Yeah. But also with this viewfinder, it allows you to essentially rotate 180 degrees, and then you can use the device like a monocular device. Yeah. So again, for that external thermography, the flexibility to be able to move the lens can be very, very useful, particularly for external applications, and that could be utilities or it could be building applications where you're having to look up at a facade of a building. It's much more comfortable to have your head in a normal position, looking down at the screen while you actually manipulate the lens itself. Yeah. So from a design perspective, that's the biggest design change in regards to your standard TXXX pistol grip type of design. It also means that you've got a slightly larger screen to use on the device as well, and you've got some additional functionality on these cameras. So for example, we have a P button on the bottom, and we have a P button on the back of the camera. Yeah. Which is here. Just that. The T-series has two programmable buttons. Essentially what you can do with either of those buttons is independently give them a function. So for example, we could choose to switch between still and video, or we could choose to switch between different temperature ranges. The idea being is it allows you to tailor the device to suit your application. There's a little bit more functionality within the T-series range of camera as well.
It all seems to be geared towards user convenience.
Yes, I mean ultimately These cameras are an investment for people, and it's about trying to give them as much functionality as possible, but not only have the functionality, but to be able to access that functionality easily. When we look at the rear of the camera, we have a nice large screen to use. We have a navigation pad here, so it's either touch screen, or if you're wearing gloves, you can have the ability to access these buttons really easily because they're nice and wide apart, so there's no chances of really hitting multiple buttons. And then you have the hand strap on the side to take the weight of the camera because of the size of the lens block that we've got, for example.
High functionality, minimal effort.
Yes.
So if you were to rank the camera models within the range, how would you go from entry level to flagship?
So if we look at the 500 series, T530 would be your starting point in this range.
Yeah.
320 by 240 detector, 76,800 pixels. You've still got a lot of information in that thermal image. You've still got a lot of clarity.
And then all the way up to the T1020.
You're substantially going up in cost as you move.
Oh, yeah.
And it's not just thermal resolution which you gain. There are other functions within the devices, and again, all of the specifications for each device is available either on the tester.co.uk website or the FLIR website.
So given the differences in specification and design, are these models particularly well suited to certain types of application?
The beauty of thermography is you can invest in a camera for one or two particular applications, but then you find out there's a whole host of other things that you can do with the thermal imaging camera.
Yeah.
And it's even things like tracing water leaks. People don't think of something like that as an application for the thermal camera, but as water evaporates, it cools.
Yeah.
So you can trace water leaks very, very easily with thermal cameras. So it's difficult to tie down a specific application, but with the viewfinder, the T800 series definitely lends itself to more to external thermography.
Yeah.
I mean, the fact that you can get the same resolution camera in both the 500 and the 800 series, the viewfinder then is the main difference in regards to reducing that effective glare on the screen outside. So I would say utilities tend to opt for the 800 series, 865, some opt for the T1020. Again, because of that detail, that thermal resolution. If you're looking up a tower or a pylon and you're looking up at some insulated discs, if you're using the T1020 with a 6-degree lens, it's really going to bring that image to life within the frame.
Yeah.
Because what we're trying to do with a thermal image, you want to get as much of the object in the frame as you can. So utilities definitely for the 800 series, and certainly building applications lend themselves very well to either of these models.
Yeah.
Again, if it's external, the viewfinder is useful, but either way, the rotating optical block is the big advantage with the building applications and external thermography. You can still use them inside, so therefore, if you invested in this style, you still have the ability to do internal and external thermography. So it's hard to specifically say, but anyone who's interested in industrial maintenance, electrical, mechanical process, these cameras have a definite use and an advantage.
So why should I invest in a Teledyne FLIR T-Series thermal camera?
Ergonomics. So therefore, the ability to rotate the optical block.
Yeah.
The functionality of having the two programmable buttons, the larger screen, the viewfinder if you opt for the 800 series, if that's going to be of use for you in your daily thermography tasks. Ultimately, it's the power and the functionality within a relatively small footprint in regards to the size of the unit, and the additional functionality such as GPS, radiometric video, voice recording, just like you get on the TXXX range. But the main difference is again, slightly larger working area with the additional benefits of the rotating optical block.
You mentioned radiometric imaging. Could you just explain again what that means?
Yeah, so radiometric images, essentially it's an image with temperature data included in the image.
Yeah.
So in other words, we gave the analogy previously of a thermal detector based on a pixel count. Yep. So if we look at a T530, which is a 320 times 240 detector, 76,800 measurement points. Each one of those points can be identified to give a temperature. Yep. So that's a huge amount of information, and all that information is included in a radiometric image. So essentially, I use the analogy of an Excel worksheet: 320 columns, 240 rows, 76,800 cells. Every cell has a temperature. That's the amount of data you get in one thermal image.
So in theory, you can pinpoint the exact temperature of a particular pixel.
Yes.
Yeah.
So it allows you, with the analysis software, Thermal Studio software, you can really look in detail at the images that you capture, should you need to look at what we call it quantifiable data. Each place you put a marker, you're going to get a temperature at that point. So it's the level of detail that you're collecting at the time, which is really important.
Yeah. And you've mentioned the optical block a few times. Can I just clarify, is that 180 degrees that it rotates to?
It does, yeah. So essentially, we're going from a device in this form where you can still look up, but you can look nice and comfortably down at the screen. Or if we're outside, we can look at using a device like a monocular device.
Yeah, they're compatible with a number of lenses, different sizes, and also dual field of view lenses.
Yes, yeah, well, the dual field of view lens is quite a new innovation for Teledyne FLIR. So it's called Flex View. So what we have on the side of the camera, we have a little toggle button. So this toggle button allows the user to change between two fields of view on the camera. You can actually assign one of the program buttons to also change the field of view in the lens. But essentially you've got a 14 degree and a 24 degree lens included in the one body.
Yeah.
And it's an optical lens, so this isn't a digital zoom, because these cameras have the ability to zoom up to 8 times digitally.
Yeah.
But when you zoom a digital thermal image, it can make the image look less clear because it pixelates as it gets closer. Whereas this is a true optical change. So without having to open the lenses up and take them out and swap them around, you can have 2 in the one field of view. So that's what dual field of view is, flex view, 14 degree or 24 degree options.
Yeah.
But then we also have standalone 14, 24, 42 degree lenses. And we have macro lenses as well. So you can also utilize these cameras for kind of a close-up of a printed circuit board or electronic circuits. You know, you can mount these cameras onto tripods.
Yeah.
And with a macro lens, you know, up to 3 times macro lens on the T-Series, allows you to get really close to the small detail. So we can be looking at very tiny potential objects, and the field of view in the camera with a macro lens just enhances your ability to be able to see really small targets really closely.
Now, there's been a new innovation from FLIR, the 80 degree lens.
So the 80 degree lens is compatible with the T-Series and coincidentally the TXXX series we've spoken about before. It's one of its key uses is, for example, we have another product in the range called IR windows.
Yeah.
So IR windows are made of a particular material that the cameras can essentially see through, because thermal cameras can't see through normal glass.
No.
And if you have an IR window fitted into a switchboard, for example, or into a cabinet, ideally you want the best range of view you can to be able to see what's inside that cabinet. And the ability now to go to 80 degrees lends itself really well to that kind of application.
They can be used interchangeably, can't they?
They can, yes, because essentially we have what's called auto calibration lenses. So when you remove a lens, and to be fair, to remove a lens, what we need to do is we twist the front and pull the lens out.
That's easy.
What you do is then you can install a new lens, and it can either be purchased and calibrated at the time with the camera.
Yeah.
Or if you decide that you have a limited budget now, but in 6 months, 12 months time, you'd like to invest in another lens, you can purchase the lens as a standalone. It comes with a set of instructions that allow you to calibrate the lens to the camera.
Yeah.
So it just means that it gives you the flexibility to, in days gone by, you used to have to send the camera back to the manufacturer. Now you have the ability to upgrade your kit, if you like, as you go through.
Yeah.
So you could add, if your budget stretches to one lens to begin with, you can invest in whether you want wide angle or telephoto or a standard 24, and then you can add to it.
Yeah, it basically eliminates any downtime, doesn't it?
And sometimes objects that you're looking at are, we could be looking at overhead buzz bars, for example. Now, overhead buzz bars are a lot further away than if you're looking at a switch cabinet. So you might be a metre away from a cabinet.
Yeah.
You might be 10 metres away from your buzz bars or more. So having the ability to either use a dual field of view lens, which is a simple press of a button to toggle to 14 degrees, will bring those buzz bars closer. But by the same token, you've got that flexibility there either way to invest in standalone lenses as well.
And could you talk us through the various focuses? Is that the right word?
Yeah.
Manual, auto.
One of the key things that you can't change after you capture an image is the focus.
Yeah.
So the software that we have, Thermal Studio, is fantastic. You can analyse to your heart's content in regards to post capture. But what you can't do is you can't refocus an image. And ultimately, it's the user's responsibility to capture a well-focused image, because ultimately an unfocused image or a poorly focused image isn't as accurate. So from a perspective of onboard functionality, we can have still the ability to manually focus, which some people prefer sometimes, automatic focus, and it can be either continuous. So if you're looking at a moving object, you can set continuous autofocus and it will track. Or we have the ability to autofocus based on either a laser point. So the camera will fire a laser to the target and will focus to the point of the laser. Or you have the ability to set the function to focus on thermal contrast. the device will look at the best thermal contrast in the frame, and it will align the focus to suit the thermal contrast. And when we talk about thermal contrast, we're talking about edges of objects normally, or differences between objects. You know, we might have a hot fuse here, which is next to a cooler terminal block.
Yeah.
That's a good thermal contrast. So the camera will try and focus the best that it can.
Yeah, it's all about ease, efficiency and accuracy, isn't it?
It is, yeah.
So we've talked about the focus modes, but what about the imaging functions? We've got MSX imaging and Ultramax. Could you talk us through those, please?
Yeah. So MSX stands for multispectral dynamic imaging. And essentially what it does, when we look at the lenses on any of our thermal cameras, you have the larger lens, and you'll have a 5 megapixel digital camera. And what it means is every time you press the image capture button on the camera, it's taking 2 images at the same time. So it takes a 5 megapixel digital and it takes a thermal image. Those can either be used as a joint image within the software, so you can mix picture in picture, or you can blend, or you can manipulate them how you like. But ultimately what MSX does, it uses the detail from the visual digital camera lens, and it enhances the thermal image with that visual detail. So for example, if we were to look at this box through the thermal imaging camera, we'd just see the shape of the box. We wouldn't see the flare on the front, typically. Whereas with the MSX engaged, you will see the detail of the writing, such as flare. And that becomes useful if you're looking at, we could be looking at a motor, for example, with a rating plate on, could have some pertinent information on that. We could be looking at location, description label on a particular switchboard. It could be that we have a lot of cables that were going into a contactor or a terminal block, and you can enhance those edges using the MSX feature. So it's a useful feature which can be turned on or turned off. It can be turned on in the software or turned off in the software as well, so you don't have to record an image in MSX. The fact that it takes 2 images at the same time every time means that data is already within the thermal image to be utilized in the software. Ultramax is different. So these cameras are already, if you know, we mentioned the T865 or the T560. Both of those models have a 640 by 480 detector. So 307,000 and some spare change in pixels. If you take an image with Ultramax turned on, it essentially multiplies the resolution of the thermal image. So when it takes a little bit longer to capture the image, and there's a little blue spinning disc when you do so, but what it's doing is taking multiple images at the same time, and then it allows the camera to interpolate. So you're enhancing the pixel count within the image. So going from 307,000 pixels to over 1 million. So over 1 megapixel when it comes to Ultramax on one of these 560 or 865 cameras.
That's also radiometric, isn't it? So
it's also radiometric, yeah. You can analyze again to your heart's content with the software.
So Meterlink compatible as well. Could you talk us through that as well, please?
Meterlink is essentially a way to use the Bluetooth capability to connect to a suitable recipient device. So within the FLIR tester measurement range, we have products which are Meterlink compatible. So therefore you can link the device to a camera. And essentially, you know, we could be looking at a current clamp which is giving us an amperage of the current flowing through a circuit. And that data can be attached to a thermal image. Ultimately, the thing about thermal images, we can look at something today which can look elevated temperature, but why is it elevated? And if we have, for example, 3 different circuits, are all those circuits under the same load? Because if one of those circuits is under a higher load, whatever is on that circuit could appear to be hotter. Because it's emitting more energy because it's under more load. So knowing things like the current or the voltage or whatever it might be can be a useful addition when you're carrying out tomography, whether it's through Meterlink or whether it's standalone devices that you record the data off yourself. So
you mentioned Bluetooth. Do they also have integrated Wi-Fi and GPS?
So essentially, if GPS is engaged and it can be turned on or off, it just gives you a GPS location where the image was taken. This is particularly useful for external tomography. Again, applications like utilities where we could be looking at a number of towers or pylons in a day. You know, which pylon are we at? Which tower are we at? GPS location gives you the location nice and easily on a map. So when you record the image, that data is already embedded within the file record that you have.
And Wi-Fi?
Wi-Fi just allows you to connect, for example, to FLIR Ignite. So FLIR Ignite is a cloud-based service which we have, which can be set up by a user for free. You get a certain amount of capacity included, but that will cover you for literally thousands and thousands of images. Obviously, if you use an Ultramax image, it's going to take more memory, but ultimately you can get thousands of images on a FLIR Ignite account. And what it means is you can pair your device to your FLIR Ignite account. You can set your device to automatically upload images as you take them. So if it's got a Wi-Fi connection, it will send it to the cloud for analysis, either by somebody else that you can share your account with. So from a collaboration perspective and sharing data, FLIR Ignite's very useful. But it just means that you've got the data there safe in the cloud to be able to analyse at a later date. Or it could be FLIR Tools Mobile, which is an app which we have, so you can connect your devices to a tablet, again using Wi-Fi as a local hotspot.
And that also helps with collaboration and decision making as well, doesn't it?
Yeah, and it's also, if someone doesn't want to invest in Thermal Studio software, because maybe they don't want to do any in-depth analysis or create reports, they just want a receptacle and an account to be able to hold images. You know, you can do a little bit of editing on FLIR Tools Mobile. It's not, the functionality is not as big as a full Thermal Studio package, but ultimately it's still something which we offer as a part of the software ecosystem.
I just want to ask about the inspection router, please.
Yeah. Okay, so inspection router is built into these cameras as well. So inspection router is the firmware, essentially, which is accessible through the menu settings. It works in collaboration with a piece of software called Route Creator, and it will plug into Thermal Studio Pro. So what you do is you can set a route up on your Route Creator on your desktop or on your laptop, and that route could be, we're going into switch room A, we need to look at fuse switches 1, 2 and 3, basically talking around a route, which is what we call a route of asset management. So which asset do we look at first? Take a thermal image. What's the next asset? So Route Creator allows you to build that route. You then load that route into your camera. It's then accessible as a route within the camera. You engage inspection route and you choose the route. It will then say, okay, go to switch room 1, look at fuse switch A. You can then reference back to a previous image called reference image facility. So it just allows the user to be able to repeat the conditions of the earlier visit.
Yeah.
So repeatability is really important with thermography, because if we're looking at an object 3, 4, 6 months later, ideally we need to be the same distance away. We want the object to be the same size. And with inspection route, you can overlay the previous image so you can get exactly in the right position.
One of the other advantages of the route creation function feature is that it doesn't have to be the same person who repeats the inspection. So you don't have to wait for person A to inspect again in 6 months' time. You can just give it to person B and they can carry out the same. You know,
we'd always advise training. You know, you can have level 1, 2, 3 or category 1, 2 or 3, whichever you want to describe it as. But you know, within our company, we have ITC training, which we'd always advise people certainly to do a level 1 course, because that does give you a lot of understanding, not just about using the equipment, but understanding things like heat transfer and or why are things emitting more energy. But what Route Creator does, it allows you to build a route into a device, and you can give that to someone who's not qualified with thermography or is in a position to be able to carry out that role.
Yeah.
And again, this comes down to utilising resources within the maintenance team. It's not, you know, it's not easy to do more with less, and that's generally what maintenance companies have to do, operations have to do. So being able to give someone a camera and say, right, start inspection route, and it will tell the person with the camera, this is what we're going to look at first. If you look at the reference image, this is the position that was taken in the last time. All you need to do is line it up, take the image, move on to the next one. So you can set it to either automatically go to the next image, or you've got to manually select it. But if you select automatic, it will automatically go on to the next. And that means that person who might be level 1 trained has the ability to be able to gather that data to then be interpreted by someone who has more knowledge.
Yeah.
So the capture part is one part of the process, but the analysis of that image is another. But it's trying to utilise as much of the resources we can.
Quickly, could you just clarify which softwares the T-Series are compatible with, please?
Yeah, well, Thermal Studio, which is our main software package. So we have Thermal Studio Starter, which is a free option, which can be downloaded from the FLIR site.
Yeah.
It's a limited functionality, and there are watermarks on it, so it's compromised in regards to functionality. Yeah. But it does give a potential user a good look at what the software is like to use. You can upload images into it to analyze yourself, and so you can have a good try of the basic package. But then we have Thermal Studio Standard and Thermal Studio Pro. Thermal Studio Pro is the version you need if you want to use any of the plugins. So Root Creator would need Thermal Studio Pro to work. Then we also, within the ecosystem, we have FLIR Tools Mobile, which is the app, which is, for example, to be loaded onto a tablet, which is free. And we have FLIR Ignite.
Okay, so there's one more thing I want to touch on before we finish. So normally when we do one of these, we're introducing a new product, but the T-Series has been around for quite a while. What do you think is the key to its longevity?
Yeah, I think the T-Series as a range of products has been around. I mean, things like the T865 is a relatively new addition in the last couple of years, but certainly it's the rotating optical block design, but it's still got that kind of look that people recognize, and it's not too different, because sometimes you can change the look of something and it can put people off. So we've kept what we see as being a really successful design. It's been enhanced, it's been improved, it's still ergonomically very usable, but it's that reliable, successful design, which all we've done is we've enhanced over the years.
Ergonomics, ease and efficiency.
Couldn't have said it better myself.
Is there anything else you think we should know about the FLIR T-Series?
That we haven't already covered?
That we haven't already covered.
We've covered most of it, to be fair. I think, the device, again, comes in one of these nice secure cases. So from a transport perspective, security, it's all in the one place, with the ability to have additional lenses, all included in, battery charger, 2 batteries per unit. So, you comfortably got a day's thermography use through 2 full batteries. But yeah, so we've kind of covered all, to be quite honest, Jess.
And so how would you summarise them in 3 words?
Quality, reliability, accuracy.
Great, thank you.
Thank you.
Thank you for speaking with us today. We've covered a lot again. I hope you found that helpful. If you did, please like and subscribe and share this video with anyone you think it might help. If we did miss anything, please leave your questions in the comments. You can find all the information about Teledyne FLIR's T-Series thermal cameras on our website, www.tester.co.uk.